Hi everyone, this is Purnima and you're watching video lecture series on field theory. In previous classes, we are discussed about Maxwell's equations and four equations and pointing vectors. So today in this class, we are going to discuss about boundary conditions, electric and magnetic field. Come, let's go into the video. Here, boundary conditions. What is boundary conditions? When the flux exceeds the medium, when the flux exists in the medium consists of two different media that the conductions of field must satisfy and called as a boundary conditions. In the what happens, it satisfy the boundary conduction. So consisting of two different media, the conductions the field must satisfy are called as boundary conditions. For the electrostatic field, the following boundary conditions considers are important. For electrostatic field, the following boundary conditions are very important. That is what dielectric medium, conductor medium, and dielectric conductor. So dielectric medium is a dielectric interference and dielectric and free space. These are the three important medium. For electric field, the following boundary conditions. These conditions are very important for satisfying this boundary conditions. Yeah. First is dielectric boundary conditions. So for dielectric, we are going to discuss about dielectric boundary conditions. So this is a little bit tough to understand, but you have to listen. So consider a boundary. So consider now here we can see consider a boundary between the two dielectric with the permeability. This is the permeability that is epsilon 1, that is the first vector surface, and epsilon 2. Here this is one surface. This is surface number 1. This is for surface number 2. We have a boundary. This is one boundary. So we both the surface. Now we are considering this both the surface as an air and both the surface as an air. Now the for air we are now permeability epsilon is equal to epsilon naught into epsilon r1. With the surface, this is epsilon r1. This is applies to the epsilon r2. Okay, here what happens is this boundary conditions. What is E1 and E vector E1n and E1 sorry, E1 is Z, E1n and E1 is Z. So there is E2 and this one a triangle surface area. Here we are taking a particular area. So change in height and change in width, change in height and change in width, particular area. So what happens? The flux flow for a particular area. What happens here? It is the flux flow. Here, in the dielectric boundary conditions, the field in the two media can be expressed. The total field in the two media can be expressed as so first in the field, the electric field in the first media considers electric field in a first media plus electric field in a first the field in two media. We can consider the field in second media. The second media is considered as E2 T plus En T. Okay. Here, applying the equation of line integral on a closed path ABCD can be figured as ABC, then a closed path ABCD, where ABCD is given as E into del omega del W with and En into height divided by 2. Why we are making h divided by 2? Because this is the total height, but half the height in surface 1 and half of the height in surface 2. So we are dividing this height as del h by 2 and here del h by 2. Okay, del h by, sorry, 2. So del h by 2, del h by 2, and the same thing repeats here. So ET1 is equal, we know that ET1 is equal to ET2. So finally, the equation becomes like this, that is the tangle component of E vectors are equal to the boundary. The tangle component is E vector is equal to the boundary. So the ET undergoes a no change on the boundary and it is a continuous across the boundary. ET tangle is a equal and it undergoes no changes. So it is considered as continuous boundary. Okay. So dielectric, so here in this dielectric boundary, what happens is Et1 is equal to Et2, and dt1 by epsilon is equal to dt2 by epsilon. The epsilon to dt1 considers epsilon to dt2. So that the tangle component of d vector undergoes the same change across the boundary. The d vector is said to be discontinuous across the boundary. So the d vector is said to be discontinuous across the boundary. The boundary conditions. What happens is the boundary conditions, the normal components are obtained by applying Gauss law on a small pill Gauss law on small pillbox shaped volume as in the figure. Small pillbox shaped volume. So, with the surface, closed surface with respect to magnetic flux density, that is equal to Q. Here, surface integral of everything will be assumed. So, assume del H is equal to 0. Then what happens? The total get rho surface. Rho surface. This is the dielectric boundary condition. So in the dielectric media, we are taking the medium as a air, that both the medium having same media. Both the media is same. Here we are taking both the media is same. So whether it is an air, whatever, maybe both the media is same. What is the boundary condition? Okay. So this is what this. So next boundary conditions we can see in next class. Thank you so much for watching.